Okay. Wow, there's a lot of apples out there. That's pretty cool. Looking into it, kind of lots of little white apples looking at it. So I'm clearly overdressed for this event. So I'm going to put on my Jenkins shirt and join the crowd.
No, it's nothing coming off. I'm just putting it on, right? All right, there we go. That feels better. Okay.
Much better. So I'm going to try, I hope everybody's, well, first of all, congratulations to everyone for getting out here early, and I hope everybody's having a great JUC so far. I certainly am, as I try to figure out where to fix this thing on my shirt. So we're getting, well, I think I'm just going to shout and talk loudly because it doesn't matter. Hopefully you can hear me at the back. If you can't, then raise your hand. Oh, very good. Okay, so I'm going to try and cram pretty much 1 hour talk into 45 minutes without speeding up too much. And well, let's see how it goes. So my name is Andrew Phillips. First of all, thank you very much for coming here. I hope everybody's had a nice 1 hour break and got tanked up with some coffee. A little bit of sunshine is what we're doing today. And yeah, we have a couple of presentations left here after a very fun and motivating initial opening keynote by KK. It's always amazing to see those numbers. Just if you compared it to any other kind of CI tool out there, it pales in comparison. So I think we're really in a great place here. Yeah, this is the blah about me slide, which I'm going to skip very briefly. Basically, I have a lot of background in development, and I try to not forget how to code by working on a bunch of open source projects. Notably, probably for those of you who know here, I've placed a few commits on Jenkins, but I work on JClouds, which anybody who's in the cloud space and doing Java may or may not know, but a bunch of others as well. My day job is as a VP of products for a company in the delivery automation space. We're outside, so I obviously have to spend a lot of my time, and quite happily so, thinking about how to make delivery of new features kind of better, not so painful for all of us. The company side, blah, again, if you're interested in what we do, come out and talk to us. Those of you who haven't yet, basically we're in the delivery automation business. We started out with deployment automation specifically, and have expanded from there to all the other boring and annoying things that you have to do from the process of getting your code from when it's finished to out to your customer and running in production. Okay, so what are we going to talk about today? I'm going to give a bit of a lightning kind of intro to the trends, the movement around going to continuous delivery right now. And I guess it's fair to say, certainly if you speak to managers and some business people, there's a bit of confusion about whether it's called continuous delivery or DevOps or cloud or something else. Suffice it to say, I think among the technical people, we all know what we're talking about here. I'm going to give a brief recap, at least for the purposes of this particular talk, what I mean when I say continuous delivery. And then I'm going to try and talk a little bit about what that actually looks like when you try to put that into practice in a reasonably large organization. That's, again, a classic sort of day job problem we have. The vision of continuous delivery is certainly great, and I think it's pretty obvious that it's hard not to sign up to it, but when you try and do it in an organization that is more than 3 developers sitting in a room with a big PC under the desk, then there are a couple of challenges that are maybe not so immediately straightforward unless you've encountered them a few times. And based on a bunch of experience of trying to do this with a whole number of large organizations, I'd like to spend most of my talk talking about 5, well, I'm cheating actually, it's 8, but you get so something like 35 or 36% free. Tips, best practices, experiences, whatever you want to call them, of things that we've discovered are pretty useful if you want to try to set this up. And then I'll briefly talk about how you might think about having a maturity model for yourself. I know that's a grand analyst favorite term. You can call it a roadmap, you can call it whatever you like. Basically, most of us are on a journey to a certain level of continuous delivery, and we want to see how can we measure our progress along that journey. And then I'll probably talk a little bit about the kind of common automation stack that people are looking at in this particular space. And I guess one thing that goes without saying here is that continuous delivery, like Agile, like DevOps, They're not tools. They're a collection of practices, processes, principles. And tooling helps, and I'm the first person to say that, obviously coming from a tool vendor, but I'd be the last person to say, oh, look, there's a big box here and it says CD on it, and you put it in your corner and you're done. That's not the way it works. And I think anybody who tries to tell you that is, put it this way, distorting the truth at least. All right, so the classic Wikipedia definition, nothing very fancy here. What is continuous delivery? It's a set of patterns and I think it probably should be practices that can help software teams dramatically improve the pace and quality of their software delivery. All right, so basically a number of things you can do in order to make sure your code gets from the moment you check it in to the moment when it's actually running and your customers are happily using it quicker than typically happens today in large organizations where, surprisingly enough, this process can still take days, weeks, months, some cases even years, but I guess those are exceptional cases where maybe continuous delivery is not quite so advisable. I wouldn't want an air traffic control system run under continuous delivery, for instance. Okay. If you're not doing this today, or if you are doing this but can't convince your management that it's a good thing to do, we have lovely numbers to back up that you are actually in good company. These are actually from almost the beginning of the year right now. That's certainly DevOps has probably risen up in the big name confusion. But basically, getting delivery faster is a big priority for a large number of organizations for various reasons. Obviously, market pressure, the situation has something to do with it. But also the fact that the way we consume applications has changed a lot. You see so many apples here. I'm sure there's a lot of tablets and phones here as well. We just don't do that. Give me a box with a CD in it every 6 months and I'm going to install it anymore. Our model of consuming software and software services has changed dramatically. And of course, organizations need to adapt to that. People expect software to just get better kind of magically every 5 minutes or every day or so. And that's something you need to do. And we are clearly in the age when, you know, if you're the CIO and you're working for a bank and then you play golf with the CIO of another bank and they have a new funky feature in their mobile app, then you need it as well. And you need it yesterday. So there's definitely a trend here. So, okay, why? Why is this happening right now? Well, I've alluded to some of the points. Yeah, from a technical perspective, it's cool stuff, right? Nobody likes hand moving or copying files or SCPing stuff over. We want to do stuff better. We want to do stuff in a more automated way. And this is a quite satisfying and sometimes quite challenging way of getting this all to work. It's pretty hip and trendy. It's DevOps. If you're a DevOps engineer, you're pretty cool right now. It's not like being a COBOL maintainer or something like that. It's a good place to be in the IT landscape right now. It's, you know, it's recognized. Big companies, the big names we all know around here are doing it. As I said, all the cool kids do it. And then maybe a bit more realistically, it accelerates time to market. It just makes it easier and quicker for you to get stuff out there. And all of the above, these are the sample answers we have here. Well, I guess, unsurprisingly, I think the main drive is really from an organizational perspective. Our accelerates time to market and maybe a little bit of all of the above. In other words, management both believes it's a good idea and hopefully we think it's a pretty fun and cool thing to implement as well. Okay, so who here does agile development? Or whose company does that? Oh, some people have tired arms, but yeah, the sort of 60% or so, I would guess that the market rate is going right now. So this is a quote. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. There's that phrase again. Anybody know what it is? Yeah, right. This is principle number 1 from the Agile Manifesto. So if I were provocative, I would claim that if you are not continuously delivering valuable software to your customers, you're actually not doing Agile at all. But of course, we don't need to be hugely provocative here, but it bears well, it's worth bearing in mind that this idea that, okay, well, we have a sprint every 2 weeks and we have production-ready code and we put it in GitHub and there it sits. Yeah, that's what a lot of companies think Agile means, and frankly, if you go back a little bit to the goals that people have when they say they're going to go Agile, this doesn't really match up with what the goal is that we're actually trying to achieve here. And I guess this all boils down to the question, what's the value of code in a repo? compared to the value of code that's actually in use by a customer. And I think it's fair to say that value of code in a repo is close to zero from a business perspective. Of course, you need to have it there at some point, but frankly, the business value from your features comes when your customers are using your products and deciding that you're better than your competitors, you have a better travel website, you have a better insurance comparison, you have a better e-banking system, whatever. So we've all, I think, read the book and read the wiki page and seen the movie. Actually, that movie doesn't exist, so don't go looking for it. The question is, can we actually put all this stuff into practice now and try to make our customers happier and thereby also make life better for the businesses we work for? All sounds great, right? It's easy to read the book and to, you come all energized, and yay, so it's Steve Ballmer style, delivery. When you start to try to do this in a big organization, a bank, insurance company, even a big retailer or something like that, you realize that in an enterprise, there are certain aspects to trying to introduce something like continuous delivery that make the problem a little bit non-trivial. I mean, the idea of the graph is really nice. Oh, look, we have these automated jobs and they're connected, and, well, we can just start at the beginning and we go through to production, and, well, what's the problem? Well, there are quite a few challenges, actually, that I've certainly typically seen and that other people have run into as well. Applications can just be enormous. I mean, the idea that you can run a build, get immediate feedback in like half an hour, whatever it is, sounds great, but if your code takes 2.5 or 3 hours to compile and produces a 2 GB IR file, it already starts to get a little bit difficult. I mean, there is a sort of tacit assumption that you can actually relatively easily put small changes into the system and get them through, and if you have one enormous monolithic application that requires 100 services to be deployed at the same time for the thing to work, this is going to start to get tricky. Another thing about continuous delivery that kind of doesn't match very well with enterprise reality in a lot of organizations is that there is this assumption that most of the steps are automated or at least easily automatable. And that's just not true. Certainly a lot of the test phases. I mean, one of the key tenets of a delivery pipeline is that by having a lot of tests, you can get the quality guarantees that you need before you're confident enough to put this stuff into production. But a lot of this testing is manual regression testing, manual functional testing, manual performance testing, and then there's the whole release management stuff to come in a second. But basically, if you have tasks in your pipeline that take 2 to 3 days to complete, if there's no vacation or something like that, then again, that is going to limit your ability to get the kind of throughput rates that are important. Contented environments, right? That's a practical thing. I heard some discussion down here about Docker and OpenStack, and luckily, technology is coming to help us here. It's getting easier and easier to spin up new machines, to try to make clean environments available, but certainly in a lot of large companies, depending on the middleware you have, you don't just quickly spin up a WebSphere installation or portal server or something like that. There are just these 6 big environments, like the sacred cows that somebody built in the at the dawn of time, and nobody really remembers exactly how they're configured. And you have to book like 4 days worth of testing time in these environments. And yeah, well, if they're busy, then you just have to wait. And when you do get your 4 days of testing time, chances are the previous team screwed up the environment in some way. So at least 1 day of that testing time is going to be lost trying to fix the environment in the first place. So again, with these kind of constraints, this sort of nice idea, oh, we check in the line of code and brrr, bing. So that's not quite so easy. Another thing that tends to be forgotten a little bit is that typically in organizations, there's, for legal reasons, for process reasons, you don't just decide, okay, well, tests are green, so we're going to go to production. There's a whole process around it. You need approvals, you have change boards, regulations, people need to look at it, you need to have meetings and so on. And this is kind of conveniently swept under the carpet a little bit here. And again, how do you actually incorporate that in your pipeline? Certainly when you look at some of the pipeline tooling, the orchestration tooling out there that is really geared for an entirely automated process, and if you have non-automated bits in the process, then you better find another way of doing them. And so again, you lose the kind of end-to-end insight. And there's others, but I think these are some of the standard ones that we run into. So, based on that, I think to kind of sum up the situation that we see, a lot of people are convinced that this is a good thing to do, have approval that this is a good thing to do, but they're not there yet. And they know that they're not yet there yet. They're at the beginning, or they're some way along a journey towards continuous delivery. And I should say immediately, we'll get back to this in a second. Continuous delivery doesn't have to mean to production immediately. We don't have to get fanatical about this. It needs to go as far as it makes sense for your organization right now. And sometimes, the benefits mean that it has to go to production, but it doesn't have to go there straight away. Anyway, we're on a lot of people are on a journey right now, so what I can try and do here in the next half an hour or so is present some tools, some ideas, some hints, some experiences with which we can hopefully, go on that journey together and hopefully make life a little bit better for our customers at the end of the day. And so, without further ado, let's get started. So point number one, create a complete delivery artifact and move that delivery artifact through the pipeline. What does that mean? It means things like don't build a different version of your application for your dev, test, QA, production environments. It's a very standard component of a continuous delivery idea, because the point is that as you transition or promote your application through the pipeline, the quality, the tests that you run are supposed to give you confidence in the quality of that particular set of code. If the code that you're running in test is actually different code from the one, oh yeah, well it's only a string somewhere that's different, I hope so. Then what's the point of running tests against one app if you're going to run a totally different app in the next environment? But get to that a little bit more. Basically, the other thing is make sure it's really complete. Yeah, Jenkins, pretty much everybody, I guess, uses Jenkins to build like their, the EXE or MSI or Warfile or Ruby gem or whatever it is that you build. But if you think about what your application needs to really run, there's usually more stuff in there beyond the application binaries. There's like database changes that need to be made. How do you handle those? How do you bundle those in with your application? Configuration files that need to go onto the file system, or configuration settings that go into your PaaS or your IaaS, server settings, memory settings, data sources, queues, connection factories, websites, application pools. And then, of course, dependencies your app has on other components. I need a certain version of the .NET framework. I need a certain version of Ruby in the system. That's all part of the information that should be in that deliverable. Some of these are obviously files, some of them are not files, they're metadata, they're information. But if you have those all together, then I think you have a good chance to make a good start. All this kind of sounds self-evident, but some of the things we've already discussed, in practice it's a lot harder to do in a lot of projects than you might imagine. Yeah, well, there's that hard-coded connection string to our payment provider, for instance. Or, well, no, the configuration settings, yeah, we don't normally do those. We do those once, because then the JBoss will be there for the rest of time, and you never have to worry about the data source settings anymore. And another good one that I didn't mention, unfortunately, application servers have a tendency of lying to us a little bit, in the sense that they are happy to boot up without any errors, but the app doesn't really quite work. And then you start testing, or you move further down your pipeline, and you end up blowing up, and that's a bit of a nuisance. Add some smoke tests to your packages. Say when you deliver your application, yeah, these are the 3 things I need to do once the application's been installed to verify that it's actually running. Better still, of course, have a health test page, make that mandatory for each of your applications, and make sure that you can ping that health test page when the application has supposedly started, and make sure it's all green. That's not just useful for your automation, that's also useful for the poor humans who have to then go and maintain your application later. Number 2, the pipeline stage checklist. So the diagram is nice and simple. Box number 1, arrow, box number 2, arrow, box number 3. But really, who's to say what happens in each of these particular boxes in our pipeline? We all know we have a process that starts somewhere, usually with a code check-in or with a build, and that ends somewhere wherever we want it to end, deployed to production, deployed to a dark launch with a switch, deployed to QA or something like that. But we have to go and break down this process into individual segments in the middle. And we have to figure out, for each of these segments, or at least I think it's very useful, it's proven very useful to figure out who is responsible for this particular part of the pipeline. Yeah, sure, you have some smart guy or girl who put together your Jenkins pipeline in the first place. But when one day that particular job breaks, whose job is it to fix it? Is it something the QA department should be working on? Do you have a build engineering department? Is it an operational job? Is it something the developer should be working on, and so forth? Because the tendency, in my experience, tends to be you build it once, it runs, then it starts breaking, you start disabling stuff or ignoring it. Because nobody is really responsible for that particular part of the pipeline. So think about who the owner is for each stage in your process. Think also about what the input and the output for each of these stages happens to be. Input can be as simple as things like artifacts, the things that you need from the previous stage, dependencies, waiting for other things, approvals. Output can be obviously more artifacts, deployed applications. They can be also state changes. They can be quality levels that you're gathering. Think about triggers, obviously. When should a certain stage be started? Does a code commit start at the successful completion of the previous one? A change ticket being set to approved, something like that. And also, obviously, the prerequisites and gates that need to be met before it makes sense to start this stage. What does it mean for a step to succeed or fail? Again, if you take Jenkins as an example. Typically, it's did one of the steps return a non-zero error code? But you might also say, do I see something in the logs? Does something take too long? So what are the actual criteria that I need here in order to get this to work? And then, of course, failure handling. If it does go wrong, what should happen? Of course, you might say, well, we're going to stop this pipeline at that point, but do I need to notify someone? Do I need to maybe modify the pipeline in response to this? Maybe make the timeout a little bit bigger? Have something like a backup policy? All these kind of things are possible if you want to have a resilient pipeline. So it makes sense to think about these particular components. Once you have this kind of information about your pipeline, you can then start to figure out, obviously, in which sequence the pipeline can happen, and maybe more interestingly from an optimization perspective, which parts of the pipeline can be run in parallel. And so where you have your joins and where you have your parallelization and so on. As I already said, in terms of the output, don't just think about files that are produced or log files that are written or changes written to a database. Fundamentally, the purpose of having a delivery pipeline and having all these stages in the middle is gaining confidence in the thing that we're building, up to the point where we're saying it's good to go. And so we need to know, when do we really think it's good to go? How many stages or how many of the stages need to have passed? What does their pass level need to be, and so on? And of course, also at some point, I really want to visualize that. I certainly think it's very important to see, well, what's the kind of test profile for my application? Not just, oh, well, that job was green, and that job was green, and that job was green, but like, show me this version. I'm about to try to put this live. What's the kind of test profile? How did it actually perform? Am I confident enough that it's good to go? And then the feedback cycles I already mentioned. Obviously, the immediate reaction to a failed stage is typically abort the job or abort that pipeline and wait for the next one. But you want pipelines to get more resilient, better over time. So if you find that a certain job keeps failing, what do you do about that? And how do you put in place a process that says we're not just going to build the pipeline once, but we're actually going to treat it as a living thing that needs to be maintained and improved over time. Number 3, manageable units of work. So this is related a little bit to the enterprise challenge I mentioned earlier, related to these enormous builds and these enormous artifacts are produced that not only do what Maven does, download the entire internet into M2 repo, but then also bundle it up in the ear, because it's much better to have the internet locally when you run your application. So of course, a lot of the stuff that, say, KK was talking about earlier has an impact on this, because if you scale and if you have sufficient parallelization, this equation doesn't quite hold. But in general, if you have very long-running tasks, and your pipeline bottlenecks on those tasks, then that is an immediate upper limit on the speed of throughput you can get. Now, if your regression tests take 4 hours to run, and you have one environment or 2 environments in which you can run the regression test, then you have an immediate hard ceiling on how many pipeline runs you can make a day. That might be fine. The ceiling might be perfectly high enough for your particular business needs, but it also may not be. If you really want to do, say, the LinkedIn or the Etsy or the Flickr type thing, release trains every half an hour, every 10 minutes, whatever, and you have long-running tasks that are bottlenecking, you need to find a way out of that. And I think sometimes you really have to ask yourself, are we getting the right what's more important here? Do we want to have a speedier pipeline, or do we want the kind of confidence level that this particular phase or stage delivers? And of course, for automated things, this typically isn't such a big deal because the upper limit isn't really that high. This becomes more interesting and more important if you have manual tasks, because those can take days. And there, if you're using one team to do like a functional test or something, then you're really setting an upper limit for your pipeline here. Well, it's a bit old hat now, I would say, after all the announcements we've heard, and certainly if you look at like DevOps Cloud and some of the other services that are out there. But CI still, even in enterprises, it's the box that runs, it's somewhere here, my Jenkins server, it's like, oh, look, here it is, it's a little Raspberry Pi running under my desk. CI tools become critical pieces of infrastructure in your organization. If they orchestrate your pipeline and they don't work, then there's no code going out to your customers in general, and that's really, really bad. So it's of course also really, really bad to treat that as a piece of infrastructure that you just have running under a desk, and if somebody spills a cup of coffee, then you stop making money as an organization. Don't just think about resilience for obviously the master server itself, and backups, and high availability, and all the kind of things that you can either fix and build yourself, or you can go to Jenkins Enterprise or DevOps Cloud or something like that. But also think about capacity for those jobs. And we heard about mansions, using Docker or LXC as a nice lightweight way of making individual workers, or using some of the cloud plugins to do that in cloud environments. Think about how many workers you're going to need, and think about how you're going to get hold of them quickly. Of course, anybody can buy 10 new machines and manually install slaves on there, but you don't want to be reactive here. You really want to have the ability to scale quickly when you need it, especially when you have pipeline runs, because you can kind of have a perfect storm. If you have one of those matrix test builds for a mobile app, you might have to spin up 20, 25 jobs in a really short space of time. And you don't really want to bottleneck that whole thing. So yeah, you need to think about how much capacity you need to run your pipeline jobs. You also need to think about how many target environments you actually need. And so again, with things like PaaS and so on, this is becoming easier. But yeah, if you have, say, 2 pipeline runs running at the same time, and you have 5 environments in your pipeline, dev, test, QA, pre-prod, production, or something like that, then you need to have the capacity to have at least 10 environments potentially up and running. And as you have more applications, this number just gets bigger. So you need to have a way of being able to produce environments quickly, and typically then we get into the obvious kind of virtualization plus environment provisioning, Puppet, Chef solved, or if you don't want to manage that problem at all, to a more PaaS type model, if your applications can be architected to run on a PaaS, then that's definitely a good thing to look at, because you can kind of have unlimited environments at the click of a button, or indeed automated. So as I said, on-demand capacity quickly, virtualization-based and certainly cloud-based services, it's a classic boost case because it doesn't tend to be a kind of continuous usage pattern, are things to look at in this area. 15 more minutes, we'll move faster. Automation. Yeah, even though I'm a tool vendor, I'm going to perjure my soul a little bit. It's not a prerequisite for continuous delivery, but typically, depending on the kind of speed and throughput you want to achieve, it's pretty much essential to have most of your tasks automated if you want to do anything reasonably frequently and rapidly. So if you have non-automated tasks in your pipeline, think about how reliably, how frequently you can execute them, and not just, oh, well, if Steve or Jenny or whoever happens to be there on the day, then we can run the database upgrade. You're trying to do these tasks often, reliably, and humans are really bad at doing repetitive tasks often and reliably. So think about how manual tasks square with your particular delivery goals. And remember the blog, which I hope everybody does, continuous integration on $1 a day. Okay, I'll briefly recap it for those of us. It's really funny. It basically says a similar thing about continuous integration. Continuous integration is not a tool. We all love Jenkins, but continuous integration is a practice. And he goes into a funny detail in describing how you can do continuous integration with an old machine, a bell, and a rubber chicken. And the $1, of course, goes to him for suggesting how it works. So the same kind of thing goes for CD a little bit. Tooling helps, Tooling is not the only thing though, so don't forget about that. Different types of automation you're likely to need or likely to already have if you're doing this successfully. Obviously, build automation, you know anybody nowadays who still has to, well, actually I do, unfortunately, has to like build their application from Eclipse. And in the mobile world, this is still not that uncommon. Unit test automation, deployment automation, integration testing, you know, all the different flavors of testing that you can do, automating those. And then some of the more interesting ones that are less common and maybe also less easy to support with technology, automated metric gathering. But what I mean by this is not just sort of APM, App Dynamics style monitoring relic of underlying metrics in your runtime. It's also things like how do customers perceive your application? Like how quickly can I see what the feedback score is for the particular feature that I just released? It's really important if you're releasing a mobile app. The tweet stream that comes out for that application pretty soon after you go live is an incredibly good gauge of how people like your app. But how do I combine this into my gathering of quality metrics? And then, of course, we talked about this already. You don't just build this once. The whole point is to have a feedback cycle. It's a conversation. You release code, you see what people say about it, you use that to make better stuff next time and to make your process better next time. So side effect overview. And this is something that, that does typically affect automation tools that are based on running a lot of stages one by one. The thing is that if you are building a delivery pipeline, you don't just have 100 automated tasks that happen in sequence. As those tasks happen, certain state changes, if you like, happen, or side effects. For instance, when you deploy an application, or when you run the job that deploys your application to the QA environment, you want to see that there is a certain version of your application running in the QA environment. Some kind of dashboard to show this. The status of the job isn't a really good visual indicator of that. Similarly, we're talking about quality measurements. Yes, that job is green, but what does that say about the overall quality status of my application right now? Or how many environments do I even have right now? And so on and so forth. So these are the kind of things, you know, this is one of the screenshots from Alto. You want to be able to see right now which environments exist, what versions are running in them, which still have open release conditions that need to be met, and so on. You don't really want to have to re-engineer what the state of your landscape is by looking at the success or failure criteria of certain jobs. I know, I mean, I remember I used to print out a Visio like this. There was the big architecture diagram with all the machines and the version of the application running on them, and inevitably, within 5 minutes of the ink being dry, it was out of date. So people would get a pen and they'd start scribbling on it, and then they would get torn and so on. You want to have something like that, but that's something that's live, something that updates itself as your pipeline moves. Release control. So this is when it starts to get a little bit hairy and complicated in organizations. And I think it's perfectly legitimate to say that for the first instance, we're just not necessarily going to tackle this problem right now. Unfortunately, if you want to do that Agile Manifesto thing and really deliver code to your customer continuously, we're all going to have to bite this bullet sooner or later. How do we handle the kind of release conditions that are associated with the later stages, deployment to production, deployment to QA, and so on? First of all, we can kind of certainly we can put some checking in place to say, well, I'm going to have a gate before my production deployment to verify like the existence of a change ticket or the fact that it's in a certain state or whatever. But more interestingly, can I automate these gates in some way to stop the fact that a release manager has to come in and check some box or hit some promote button? Is there some way I can take that human out of the loop and say, well, I have a Jira plugin, for instance, whenever I change a ticket that automatically sets my deployment to production to green. And then maybe to take that radical thought, if you like, a step further, can we actually dispense with some of these release conditions entirely? I mean, the whole point of release conditions or change boards, advisory boards, approvals, and so on, is to try to ensure we don't ship bad stuff and break stuff and make embarrassing mistakes. But the whole point of a pipeline is to build up your confidence level to the point where you're confident enough that you're not going to break stuff. So, and this is not an easy conversation to have, but as the pipeline proves itself, certainly it's worth having the dialogue where what do we need to do in terms of testing, regression testing, maybe security testing, whatever it happens to be, to say, well, if I can prove that these tests all passed, can I regard that as an automated vote for this one is good to go? And that, I mean, certainly with some of the kind of mobile-ish or PaaS, really fully PaaS, cloud-driven stacks, that tends to be what happens, the confidence, and also some of the famous IT companies, if you like, web companies in the continuous delivery space, they don't have a huge release management overhead process because their process lives in the pipeline. That's what they trust to give them their quality guarantees. They don't need some other process outside to do this. But of course here, there's no one-size-fits-all, you know, where exactly, how much control, how much security or safety from your process you need versus how much risk you're willing to tolerate for extra speed is a decision that every organization has to make based on their own business situation. So a bank probably may be slightly more risk averse to releasing bad transaction software than it might be to releasing, say, a marketing website or something like that. Improvement metrics. Looks like I'm going to get away with the time. So it's all great to do this. We build these pipelines and we just feel good. Look, oh, it's all moving. Unfortunately, what tends to happen is if you have to justify investment, like cold hard cash, somebody, whether it's you or more likely your boss, doesn't just want to have the warm, fuzzy feeling that, oh yes, things are getting better, but they actually want to be able to point at some number, some metric, some graph, typically a nice graph or a bar chart. It has to look pretty with colors to show that really it's worthwhile, that the investment we're making in this whole delivery automation thing is really paying dividends. So you need to be able to prove this. What does this mean? It means two things. Well, first of all, it means that we have to decide what metrics we're going to use to actually measure success of our delivery pipeline. And that's not really a trivial exercise in the first place. But then, of course, it also means we have to make a baseline before we get started, because otherwise we have no way of determining whether we're getting any better. Some of the metrics I've seen come up as part of this discussion to decide what should count as a good success criterion. Throughput, in other words, how many features can we release per certain unit of time. Failure rate, or a combination of the two. How many of these features end up working or not working, and so on. Standardization, that's an interesting one. Well, that's really an enterprise problem, that if you have 100 applications that all have their own pipelines, but each pipeline is entirely different, it starts to get rather difficult to measure the relative performance of one pipeline or one application versus the other, and certainly also to apply lessons learned from one pipeline to another one. So ideally, you want to move towards a standard procedure where all your IaaS applications pretty much follow the same pipeline, because then you can compare them easily. You can also move experts around easily from one to the other. Variability of the individual stages in your pipeline. Just in terms of being able to predict how long it takes to go to production, if one task takes 1 minute most of the time, but 3.5 hours once or twice, that's a weird thing. That's different from something taking 18 minutes on average. Min-max duration per task stage, yeah, that's a kind of, instead of looking at the averages, it's looking at the worst case or best case scenarios. So yeah, if I can only tolerate, 3 hours is the max I can tolerate, how often do I hit that limit? Number of manual tasks, there's certainly more. Suggestions and always welcome, of course, please come up to me. But these are some of the ones that we see. All right. To sum up that list that I just went through, 5 plus 3, buy 5 or listen to 5, get 3 free. Complete delivery artifact. Put everything that really makes up your application together, build it once, and promote that thing through the pipeline. Have a checklist. Know what components or what stages your pipeline consists of, and know what each of those stages should be doing, who's responsible for it, what should happen if it fails. Make sure the bits you're trying to do in the pipeline aren't enormous chunks of work that effectively limit how often you can run them in the first place. And if you come up against one of these elephant, 3-4 hour compile jobs, think about what you can do in order to deal with that. Look for scalable capacity. Don't be caught out by the matrix build problem where you have 20 jobs queued every once in a while. Make sure that you have some way of getting both new slaves to run your jobs, or workers, and that you have the ability to easily and quickly create environments for your applications to run in. Automation, 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 automation. Depending on your goals for your pipeline, manual tasks are likely to be a problem, so identify them and see what you can do about them. Make sure you don't just have a big dashboard that says this job succeeded, this job succeeded, this job succeeded, this job succeeded. If you have some sort of business domain language, like version 3.5 is running in my dev environment, make sure that you have some way of seeing this easily so that everybody knows the state of your system, the state of your landscape as you're working. Release control, don't forget that as you get towards the end of the pipeline, there will be integrations with release management to consider. So be aware what the conditions are. Try to think about how you can hook those into your pipeline. Dare to think the impossible. Are any of these conditions actually replaceable simply by the quality guarantees that the pipeline offers? Finally, it's not just about that warm, fuzzy feeling that we engineers all like. It's unfortunately also about the pretty pie charts that your managers love in screenshots and in PowerPoint presentations. So make sure you define before you get started what it means for your pipeline to be successful, measure where you come from, and look how the efforts that you make to automate your pipeline actually improve or maybe indeed do not improve that particular situation. So metrics are all very well, but they're kind of rather analog in the sense that you can look at, look, 1 per day, 2 per day, 3 per day, 4 per day, you get some lovely graph. More often than not, you probably want to break down your continuous delivery implementation into certain phases that make sense. Like maybe the first goal is we want to be able to release once per day. And then you might want to be able to say we want to release 4 times per day, and then once per commit, or once per 10 commits, or something like that. Having these kind of discrete goals makes it much easier to know when to start, to know when to stop, and to define individual phases. Of course, a maturity model for delivery is more than just your strict pipeline. It also, you have to have a look at things like, does the application work properly when it's running? Do customers like it? Am I even building the right things, and so on? So feedback is really essential. Don't forget those in your model of maturity. For instance, one for feedback might be, stage 1, we're just going to get it live, and then we'll be happy. Stage 2, we're going to get it live and try to measure how our customers react. Stage 3, we're going to use that information in the next planning meeting, and so on and so forth. All right, common automation stack. Okay, I said automation, automation, automation. This is just the one we provide, as it so happens, or one of the common combinations. Basically, it's important, and this is one of the things I think everybody who's tried to build a delivery automation platform has run up against. There's lots of great tools to do the individual pieces of this particular puzzle. Environment provisioning, almost commoditized, I would say. Great tools out there to do that. Cloud management, whole bunch of APIs, on-prem, hybrid, you name it. Tasks now in the mix as well. Build automation, certainly commoditized. Jenkins by far and away or continuous integration rather, by far and away the runaway leader. Deployment automation, a bit of a newer space. The problem is, to make this an efficient factory, these bits all have to talk to each other. If you spin up a new environment, your continuous integration needs to know that this environment exists, or your deployment automation does, otherwise you can't really deploy to it. So there's still this whole nasty gluing and information passing and keeping stuff in JSON bags and doing queries, and suffice it to say something more can be done here to make that experience a bit more painless. And of course, PaaS platforms, fully managed platforms do this, but in a lot of enterprise environments, the restrictions that they still impose make them not suitable for a large number of applications run by an enterprise. We'll skip the lightning demo. You can come over to the booth for us to do that. So I would obviously like to thank myself, all our sponsors, including us, but of course also CloudBees, especially for putting on the event, for putting so much time into organizing this, and more importantly, you all for coming and making the event what it is. More information if you want to. You don't need to write down the links. Just ask me for the slides or download them. There's a couple of interesting things. Top one's fun for your boss to convince him or her that other people are doing this as well. There's an interesting D-Zone ref card that doesn't talk about the dream vision of continuous delivery as it could be, but pretty much about what we just discussed, what you have to do to get started. And then there's some more references and links on our website. And with that, and it's 14 minutes past. Thank you very much. There's my contact details. More than willing to have any discussions, conversations, suggestions with you. Otherwise, come back and see us at the booth. Thank you very much.